B Academy classes. Today we are going to deal with the questions from the mathematical economics part, which was asked during the previous NET exam, which was conducted on December 2019. A significant number of questions were asked from this portion, which shows the importance of mathematical economics. Now let's see in detail. So we need to find, considering these four equations, when would k be equal to 4 in these four. So we will do that. So consider the first option. So when you look here, MBC is represented by the coefficient of y. Okay, so 0.8, 0.5, 0.75 and 0.4 represents MBC. Now we will look at the first option. Considering the first option, MPC is denoted by 0.5. So when you look here, 1 by 1 minus 0.5, which is 1 by 0.5. So obviously this is not equal to 4. Now let's look at the second option. B, 1 by 1 minus 0.8, which is 1 by 0.2. So even this is not equal to 4. Now let's look at the third option. C, 1 by 1 minus 0.75, which is 1 by 0.25. Okay. So when you look here, you get this as 100 by 25, which is equal to 4. So the answer is option 3. C equal to 200 plus 0.75y. Only in this option you get k as equal to 4. Let's look at the second question. So the question is, given the savings function s equal to minus 20 plus 0.2y and the autonomous investment is given, which is 100 million, the equilibrium level of consumption would be. So we need to find the equilibrium level of consumption. So here autonomous investment is given, which is 100 million. So let's assume that all the units are expressed in million rupees. Okay. So at equilibrium, saving is equal to investment. So we will equate the savings function to investment, which is minus 20 plus 0.2y is equal to 100. From that we are finding the y or income. So we get minus 20 plus 0.2y equal to 100. 120, taking this 100 to this side, you get 120 is equal to 0.2y and y equal to 1200 by 2, which is 600. Now we need to find the equilibrium consumption. So we know that y is equal to c plus I. So we have already got y as equal to 600. So now 600 is equal to c plus I is given in the question as 100. So c plus 100, c equal to 600 minus 100, which is equal to 500. Okay, which is option 1. I will just explain it once more. At equilibrium, saving is equal to investment. So we are equating the savings function and investment. So investment is given as 100. So you get minus 20 plus 0.2y is equal to 100, y is equal to 600, and again we know that y is equal to c plus I. So now equating this, you get 600 is equal to c plus 100 and c is equal to 600 minus 100, which is equal to 500. Okay, now let's look at the third question. This is from Kopler's production function. The production function is given here, which is q equal to 100 L raised to 0.7 k raised to 0.3, and certain statements are given. We need to see which of them are true. Okay, so the first statement is, it is a linear homogeneous production function. So if you look at the output elasticity of labor and capital, you can see that output elasticity of labor is 0.7 and output elasticity of capital is 0.3. So when you add that alpha and beta, alpha plus beta is equal to 1. So we can confer that it is a linear homogeneous production function with constant returns to scale. So the first statement, it is a linear homogeneous production function, is true. Second statement, it is characterized by constant returns to scale. Even that statement is true since alpha plus beta is equal to 1. And the third statement, it is having zero elasticity of factor substitution. We look at the fourth statement and then come back to the third one. So the fourth statement is, it is characterized by unit elasticity of substitution. So we know that in Kopf-Flass production function, the elasticity of substitution is equal to 1. Therefore, the third statement is not true. So the answer is, it is having zero elasticity of substitution. So that is the wrong option. At the next question, this is from input-output analysis. We need to arrange the following economist who has contributed towards input-output analysis in the chronological order. So the option is answer C. Okay. So Quesnay, who is a physiocrat, he contributed first towards the input-output analysis in his theory. Then Karl Marx, then comes Leontief, and finally Hawkins Simon. This is a fifth question. The total cost function of a firm is given, which is 1 by 3 q cube minus 3q square plus 50q plus 300. We need to find the marginal cost when q is equal to 10. So we know that the formula for marginal cost is dTc by dq, that is the differentiating the total cost with respect to the quantity. So we will differentiate this function. Differentiating this, we get 3 by 10 q square minus 6q plus 50. 3 by 10 q square minus 6q plus 50. Now we need to substitute the value of quantity in this one, which is q is equal to 10. So substituting that, we get 3 by 10 into 10 into 10 minus 6 into 10 plus 50. So you get 30 minus 60 plus 50, which is 80 minus 60, and the final answer is 20. So which is option A. So this question is, you have the total cost function given, you need to find the marginal cost when q is given. So marginal cost is dTc by dq, differentiating the total cost and substituting the value of quantity, we get the marginal cost, which is equal to 20. This one is a match the following question. This is very simple, we will just match it. So the first one is Slutsky. Slutsky is associated with consumer behavior analysis. Okay. So next one, Arrow. Arrow, he is associated with C is production function. Then Leontief. Leontief is associated with input-output analysis. And Danzig, he is associated with linear programming. So that is the answer for this question. We need to find the inverse of a matrix in this question. So there is a 4 into 4 matrix given. First we need to understand how to find the determinant of a 4 into 4 matrix. So first we will see that. Okay. So this is a matrix given which starts with 2. So the A11 is 2 and there is a speciality with this matrix. So if you look here, this is a diagonal matrix where elements or non-zero numbers are present only in the principal diagonal, all other elements are 0. So, in this kind of a matrix, in order to find the determinant, we need to multiply the elements in the principal diagonal. So, the determinant of this matrix is 2 into 4 into 5 into 1, which is 40. So, we know that the equation for finding the inverse of a matrix is A inverse is equal to 1 by determinant of A into adjoint of A. So, we have already found the determinant, which is 40. Otherwise, suppose that this is not a diagonal matrix. We will see how to find the inverse determinant of such a matrix. So, taking the first element 2, cancelling out the corresponding row and column, we get a 3 into 3 matrix here. See, 4 0 0 0 5 0 0 0 1. Okay. Now, the first element 2, you need to multiply the first element 2, which is A11, into the determinant of this 3 into 3 matrix. Okay. So, 2 into 4 0 0 0 5 0 0 0 1. Okay. Now, we know that we need to alternate the signs of the or we need to change the signs of the alternate element. So, if here it is positive, then negative, positive, negative, the usual way of finding the determinant of a matrix. So, taking the second element, which is 0, that is negative 0, you need to write the determinant by cancelling out the corresponding row and column of that element. So, cancelling out this column and row, you get this matrix 0 0 0, then 0 0 0 0 again 0 0 0 and 0 0 1. Okay, just let us check out again. Cancelling out this row and column, you get 0 0 0 0 5 0, sorry, here it is 0 5 0 and 0 0 1. Okay. So, this is how we find the matrix of we find the determinant of a 4 into 4 matrix. Since here this is a diagonal matrix, we just, in order to find the determinant, we need to multiply the elements in the diagonal. So, here the determinant is 2 into 4 into 5 into 1, which is 40. Now we need to find the cofactor of this matrix in order to find the inverse. Okay. So, in order to find the we know that adjoint is the transpose of the cofactor. So, first we need to find the cofactor. Now, look at the options. These are the 4 options available. So, if you look at the options, you can see that only there are non-zero numbers are present only in the principal diagonal. Other elements are 0. Okay. So, we just need to find the cofactor only of this principal diagonal in order to find the answer of this question. So, first we will find the cofactor of A11. In a 4 into 4 matrix, in order to find the cofactor, if we are taking the first element, that is A11, deleting the corresponding row and column, you get a 3 into 3 matrix. So, when you find the determinant of that 3 into 3 matrix, that is a cofactor of A11. So, the same procedure is followed for every other element. So, if you are taking A22, deleting this row and column, you get another 3 into 3 matrix. Find the determinant of that matrix, that is a minor. So, minor into minus 1 raised to I plus j is a cofactor. So, if you look here, cofactor of A11 is, see, you can, while deleting this row and column, you get this 3 into 3 matrix 4 0 0 0 5 0 0 0 1. Okay. So, again this is a diagonal matrix. So, just multiply these numbers 4 into 5 into 1, you get 20. So, this is a minor into minus 1 raised to I plus j, where I represents the corresponding row and j represents the corresponding column. So, for here it is A11, you know that minus 1 raised to 2. Okay. So, 20 into minus 1 raised to 2, again 20 is a cofactor for A11. Now, when you look here, in order to find the inverse, you need to divide you need to divide the adjoint of that particular matrix by the cofactor, by the determinant. So we have the determinant which is 40 and we have the cofactor 20. Dividing this 20 by 40, you get 0.5. Okay. So we can conclude that the first element, which is A11, in the answer would be 0.5. So here's, look at option 3 and 4. The first element is 0.5. So you can clearly rule out the options 1 and 2. Okay. Now, so you have two options here, and if you look at this A22, again A22 is same 0.25, 0.25. So now let's look at A33. So A33 here it's 0.2 and 1. So we need to check which is the right one. So taking A33, see, deleting the corresponding row and column, you get a matrix which is 2 0 0 0 4 0 0 0 1, and the determinant of that matrix is multiplying the diagonal elements, which is 2 into 4 into 1, you get 8. So 8 is a minor and the cofactor is 8 into minus 1 raised to I plus j. So here it's A33, so I plus j is 3 plus 3, so minus 1 raised to 6, again it's 1. So the cofactor is 8 and you need to divide the cofactor by the determinant, which is 8 by 40. So 8 by 40 gives you 0.2. So if you look here, option 3 gives you 0.2. So the answer is option 3. Okay. So you don't need to find the cofactor of the entire elements. By looking at the option, we can rule out two options. This is 1 and 2 can be clearly ruled out, and finally the answer is option 3. We have got A11 as 0.5. Okay. So A22 is same for both the options 3 and 4. Now looking at A33, there is a difference in the option. There is a difference in A33 for option 3 and 4. Now we need to check that by while checking the cofactor of A33, you get 8 as a cofactor. Now for the inverse, you need to divide the adjoint of A by determinant of A. So while dividing the determinant is 40, while dividing the cofactor by the determinant, you get 0.2. So you can confirm that the answer is option 3. This question is from Copley-Flux production function. We have already done a question similar to this. So the question goes like this: there is a linear homogeneous Copley-Flux production function. Two inputs are used, which is capital and labor. The share of capital and labor are respectively 1 by 3 and 2 by 3, which means this is okay. So if this is the equation, alpha is 1 by 3 and beta is 2 by 3. That is the output elasticity with respect to capital and with respect to labor. Okay. Now rate of growth of capital and labor are 6% and 3%. That is 6% is delta K by K and 3% is delta L by L. And the rate of growth of output is 6%. That is delta Q by Q. We need to find the rate of growth of output due to total factor productivity. So we need to find delta A by A. We have all the elements necessary to find delta A by A. So we just need to substitute these values in this equation in order to get delta A by A. So substituting this, you have delta Q by Q, which is 6%. So 6% is equal to alpha, which is 1 by 3, 1 by 3 into delta K by K is again 6%. plus 2 by 3 into 3% plus delta A by A. Okay. Okay, so you get 6 equal to 2 plus 2, 4. 4 plus delta A by A. So, you get delta A by A is equal to 6 minus 4, which is 2%. Okay. So, the answer is option 2, 2%. Okay, we have the equation delta Q by Q is equal to alpha into delta K by K plus beta into delta L by L plus delta A by A. We need to find the total factor productivity, which is delta A by A. All the values are available in the question, are given in the question. So, we just need to substitute these values in this equation in order to find delta A by A, which is 2%. Now, we have seen in detail almost every question from this area. We will be uploading more videos soon. Please stay tuned to catch up those videos. Thank you.